What is lightning? This powerful force of nature is one of Earth's most spectacular phenomena. Lightning is a powerful electrical discharge that occurs during thunderstorms. It's essentially a giant spark of electricity. Lightning can travel between clouds, from clouds to the ground, or from the ground to clouds. Cloud to cloud lightning occurs when electricity travels between two clouds. Cloud to ground lightning is the most common type we observe, where electricity flows down from clouds to the earth. Ground to cloud lightning occurs when electricity flows upward from tall objects on the ground to clouds. Lightning is incredibly hot. It can reach temperatures of 30,000 degrees Celsius, which is 54,000 degrees Fahrenheit. This is about 5 times hotter than the surface of the sun, which is only 5,500 degrees Celsius. To put this in perspective, let's compare lightning's temperature to other hot objects. A cooking flame is around 700 degrees Celsius. Lava reaches about 1,200 degrees. The sun's surface is 5,500 degrees, but lightning at 30,000 degrees is dramatically hotter than all of these. This extreme heat is what makes lightning so dangerous and powerful, capable of causing fires, damaging structures, and creating thunder through rapid air expansion. Cloud electrification is the process where thunderclouds develop powerful electrical charges. Thunderclouds contain millions of ice crystals and water droplets in constant motion. When these particles collide within the cloud, they exchange electrical charge. Through a complex process, ice crystals tend to gain positive charge, while water and grapple particles become negatively charged. The lighter ice crystals carrying positive charges rise to the top of the cloud. Meanwhile, heavier water droplets and grapple with negative charges sink toward the bottom. This separation of charges creates a strong electric field within the cloud. The electric field flows between the negatively charged bottom and positively charged top. As the charge separation increases, so does the strength of the electric field. When this field becomes strong enough, it sets the stage for lightning formation. As a thundercloud develops, a remarkable electrical process takes place inside it. Negative charges accumulate at the bottom of the cloud through a separation process within the cloud. These negative charges repel negative charges on the ground surface, leaving the ground positively charged. This separation of charges creates an electric field between the cloud and ground. As more charge separation occurs, the electric potential between cloud and ground increases dramatically. This electric potential can reach over 100 million volts, which is like stretching a rubber band until it's ready to snap. For perspective, that's over 400,000 times stronger than the electricity in your home. As the negatively charged step leader descends from the cloud, it creates an electric field that induces positive charges in objects below. Tall objects on the ground develop strong positive charges in response to the approaching negative charge. As the step leader approaches the ground, positively charged streamers begin to reach upward from these objects. In a critical moment that happens in microseconds, one of these ground streamers connects with the descending step leader. This connection completes the electrical circuit, determining exactly where the lightning will strike. The tallest object, or the one with the strongest electric field, will typically be the connection point. Once the step leader connects with ground streamers, the circuit is complete. The return stroke is a powerful surge of positive charge moving upward from the ground through the ionized channel. This return stroke is what we actually see as the bright flash of lightning. The massive current flow typically reaches 30,000 amps. Contrary to what most people assume, the bright flash we see is actually moving upward from the ground to the cloud. A single lightning strike often consists of multiple return strokes traveling through the same channel. These multiple return strokes can happen in quick succession, creating a flickering effect that we see in some lightning strikes. Thunder is created when lightning heats the air around it to extreme temperatures. When lightning strikes, it instantly heats the air to approximately 50,000 degrees Fahrenheit. This extreme heating causes the air around the lightning channel to expand explosively. The rapid expansion creates a powerful shock wave that travels outward in all directions. This shock wave is what we hear as thunder. We see lightning before we hear thunder because light travels much faster than sound. Light travels at approximately 186,000 miles per second, while sound travels at about 767 miles per hour, or roughly zero point 0.2 miles per second. When lightning strikes, the light reaches us almost instantly. But the sound waves, which are traveling much slower, take about 5 seconds to reach us for each mile of distance. This time difference allows us to estimate our distance from a lightning strike. Simply count the seconds between seeing the flash and hearing the thunder, then divide by 5 for distance in miles or by 3 for kilometers. Cloud-to-ground lightning is the most common and dangerous type of lightning. It occurs when a negatively charged stepped leader descends from the cloud and connects with a positively charged streamer from the ground. This type is most extensively studied because it causes the most damage and injuries to people, structures, and electronics. Intra-cloud lightning occurs entirely within a single cloud. It happens when charges separate within the cloud, creating lightning that travels between differently charged areas of the same cloud. This is actually the most frequent type of lightning, appearing as diffuse flashes that illuminate the cloud from within. Cloud-to-cloud lightning occurs between two separate clouds with different charge potentials. In this case, electrical charges travel through the air between the clouds, equalizing their electrical potential. These discharges are often visible as bright horizontal flashes during thunderstorms. Ball lightning is one of the rarest and most mysterious types of lightning. It appears as a glowing, spherical electrical phenomenon that can hover in the air or move erratically near the ground. Unlike other lightning forms, ball lightning can last for several seconds to minutes, and its exact mechanism is still not fully understood by scientists. Lightning safety is critical during thunderstorms. Let's learn how to stay safe. When thunder roars, go indoors. Seek shelter in substantial buildings or hard-topped vehicles. Never seek shelter under a tree. Trees are frequent targets for lightning strikes. Follow the 30-30 rule. If you count less than 30 seconds between lightning and thunder, lightning is close enough to strike. Remain in a safe location for 30 minutes after hearing the last thunder. Lightning can strike up to 10 miles away from the parent storm. This is known as a bolt from the blue. If you're caught outside with no safe shelter, there are emergency actions you can take to reduce your risk. Crouch down low with your feet together, cover your ears, and minimize contact with the ground. Stay in this position until the danger passes. Remember these key lightning safety rules to protect yourself and others during thunderstorms.